Climate in Kerala. Nice. So as soon as we go live on social, I'll start the session. Awesome. Are you guys able to see my screen, which should say coding basics written there? Awesome. Great. So hi, welcome everyone to today's session. So as you know that I've developed something called the Web3 developer course, and this is part of the interface of that. So I'll of course share the link with you guys right now, so that if you want, you can also open this up while I'm going to be taking the session today, or you can have a look at it later. Just give the page a few seconds to load. It's quite a long page. So the entire course has been divided or put into one single format. So here when you click, you'll be able to see the entire menu. All the topics are here, and you can just click and navigate it. So you don't have to go to multiple pages. It just kind of makes it easy. And I've also put a lot of code samples in. So what we're going to talk about today are some basic coding samples that all Web3 developers should know about. The first thing that I want to talk to you guys about is something called web storage. Now this web storage API, it enables browsers to securely store key value pairs. So usually you could use it to keep sensitive data like private keys, but we've also got to remember that never should we place these sensitive keys in plain text format. So they should always be encrypted. And I'm going to come to that. I'm going to show you guys how to do the encryption also. So far, is it clear? Am I audible, visible? The screen's all clear to you guys? Can you just give me a quick yes? Awesome. Now, when we talk about web storage, there are two kinds, right? And this is by default built into your browsers. It works on all the browsers, but I primarily use Chrome, and I recommend you guys also to use that. Of course, Brave also does pretty well, but I've noticed there are always some problems with Safari. Now, this web storage can be of two types. One is what we call as session storage. That means for every website that the user accesses, right? Some part of the storage area is allocated as long as the browser is open. You can refresh as many times as you want, but the moment you close that browser, the data which you have stored in session storage is gone. However, if you use local storage, even if the browser is shut and then reopened, the data is going to remain there. And as a user, I would want you guys to see how it works. So just go to your Chrome, and when you right click and you have this option called inspect. So when you click on inspect, then go to application and then go to storage. So you will see something like this. So as you can see, when we do inspect, we see this whole thing here. Click on the application, then click on the local storage and later session storage. Now, when you click on this file here, you will be able to see the data that has already been stored in your local storage. Now, one thing that I want to talk to you guys about here is that some of you may feel, why don't we just use cookies for this? So for a very long time, we used to use cookies, but cookies have a limitation in terms of the size of data that we can put, as well as they're kind of, I would say honestly, a little outdated. So it is much better to use the local storage and the session storage. So there are four basic kinds of commands here. If we do a set item, it is going to add a key and value to storage. Now, when we want to see what we have added, now here you got to remember one thing. If your website has created some information on the browser for the user, only your website will be able to read it. So you have to be very specific about the URL. So I've noticed that if you say www.rohasnagpal.com places it, and the user then goes to rohasnagpal.com without the www, if you've supported that in your domain, the data will not be accessible to you. So make sure it is identical, the domain, where you are setting from and where you are trying to retrieve that data. So set item, get item, simple. Now, if we want to remove a particular item, we are going to say remove item. And if you want to clear everything that we have placed, we would do a clear. So these are the four kinds of options that we have. Any questions till now? Just let me know. Now let's have a look at the first code. So suppose I want to create some information and the key is name and the value is Sanya. So all you've got to really look at is this one single line that's doing everything for you. So we are doing local storage, set item, name and Sanya. Now this could be anything else. We could always say private key and then we could put the contents of the key, of course, as long as we've encrypted it. So it's up to you what the key value pairs are. All the rest of the code that you see is just basic stuff, like first we are checking whether or not the browser supports. If it doesn't, it's going to give this standard error. But this is the most important line. So if you want to see it in action, we can just click here. Now, I'm not sure whether the new tab is visible to you guys. Are you able to see a yellow screen? Okay, so let me just change the way I'm sharing. Give me a second. Just give me 1 second more. So now are you able to see the yellow colored background screen? Awesome. So what we did there was we simply clicked on that code, and when we ran this page, it's just simply telling us that, okay, it has added the data. Now somebody asked what language are we using? We're just using plain simple HTML JavaScript. We are not using any specific like PHP or any kind of Node.js. This works default in your HTML code. So if you download this file, you will see that it is called web_storage_store.html. So it's a very plain and simple HTML file, as you can see from here also. You just remember we have to open the script tag and close the script tag. So if you guys want, you can just download this file, right click and download, and just open it up on your laptop and it will work. You don't need to do anything else. Hope that's clear to all of you. So is this part clear? The storage? Awesome. Now that we've stored it, obviously the next step is we want to retrieve. So again, for that, this simple line we are going to use, and what it is telling us is to get the item called name. So here we are presuming that we know specifically the key that we want to call for. So we are saying get item name. Now, if I click on this here, as you can see, it displays it to me that this is the value that it has picked up from the local storage. So now, depending upon what you are trying to create, you could convert this value into a variable and then do whatever magic you want to do with the application that you're building. So this is the basic code for it. So it displays it on the screen, and you can then always convert to a variable and move on. Any questions? If it's all clear, just say clear. Awesome. The next thing that we need to do is we want to suppose remove this value. So again, here, this is the single line that we need to look at. So here again, we know what the value is. So we are saying remove the item called name. Again, when I click on this, it will not display anything much. It's basically going to just remove. I've just put this message so we know that the page has worked. And once we have removed it, if we try reading it again, like suppose we go to retrieve, so you can see that the page is blank because now there is no such key left in the storage. So it will just display blank to us. And instead of remove, we also have an option to do something called clear. Now, when we do clear, we don't have to specify anything. It will clear all the data that we have ever written to that browser. Now, remember, you're not going to be able to delete what other websites have put on the user's browser. You can only clear what you have put on the browser. Any questions? Is it in JS? Yeah, so this is the native JavaScript. We don't need to put NPM, Node.js, nothing. It's just native JavaScript which is supported in your browser. So it's a plain and simple HTML JavaScript code. So you can just download all these pages and one by one you can try them. Now suppose we want to add multiple key value pairs. So here you can see now is that, so we are saying that there's a constant called person who is name is Sanya and location is India. So earlier we were just giving a name, a key pair called name and a value. Now we are saying there's one key called name, Sanya, there's another called location and India. So here we are now adding more complex data. Again, very simple. Maybe just click on it. So it has added this to the storage, and now when we want to retrieve it, that's how simple it is, and it can retrieve it to us for us in this format. So here now in your mind you can presume that okay, one could say address, another could say, I mean, public key, whatever, multiple kinds of data that you want to store. It becomes very easy to do that. So these are the different kinds of options which are available to us for local storage, and then you could do the similar thing for session storage. The only difference to remember is that in local storage it is going to last even after you shut the browser. Session storage, it is going to get removed once you shut the browser. So depending upon what the data is, you would choose whether to use local storage or session storage. Is it clear? If there are any questions, you can ask me, otherwise I'll go to the next topic. Awesome. The next thing is something called web workers. So now what happens is, you may have noticed that sometimes a web page will become unresponsive because there may be a lot of scripts running on it, right? So what happens is, if you use this web workers, which is again kind of built into your browsers, it will make the scripts run in the background without degrading the performance of the web page, right? So that's really, really useful to us, especially if we are doing a lot of stuff. Now here, it's a pretty long code, but fairly simple to understand. So what I'm going to show you here is that if we are going to see in action, let me show you what kind of this thing. So here on this page, we can, if we say start, so what it does is a timer starts to execute, but this is not going to affect the rest of the page. And whenever we want, we can stop it. So this is a very basic example. So I put a timer, but you could put all sorts of things to run in the web worker. The basic thing to remember is this will allow us to execute scripts in the background. If the page is really heavy and loading slowly, it will not degrade the performance because the scripts are going to run in the backend. Now again, the code for this is very basic. And firstly, in the main HTML part, we are obviously just saying that, okay, the result has to be declared here. And then on clicking this button, we say we are starting the worker. On this, we are stopping. The rest of the code you can just copy, but you can see the actual magic is going to happen in this JavaScript page. And the code of that JavaScript page is here, where it is going to run a timer for us. It's as simple as that. And again, if you want, you can just download these pages and have a look at them. I hope that was really clear. Any questions? Can you just give me a clear? Okay, awesome. Another very interesting feature that we can use is called a server sent item. So suppose we want a web page to automatically get updates from a server. Let's say we want to pull crypto prices. It will keep pulling it from the servers without having us to refresh the page in any way. And we are not even using any kind of advanced Ajax or anything in this. So for example, let me first show you a page. Let's look at what's happening on this page. Now, as you can see, it is going to keep publishing the date and time. So we are putting the timestamp here. Now, obviously, you may wonder why is the timestamp showing different? Because my server is not configured on IST. So because of that, it is -700 GMT. And here it is generating a random number for us. So I've asked it to generate a two-digit random number. Now, if you realize, I don't have to do anything. I don't have to keep refreshing this page. The data will automatically keep getting pulled. So I found that this is pretty useful if you are using it for things like crypto prices or any other kind of stuff. So Yagnadeep, what the web worker was doing is, the webworker.js is where the code was running, the one that we wanted executed in the backend. So that's what it is doing. You can rename the file to whatever you want. Shankar's question is, how is Web3 different from Web2? So, well, Web3 basically has certain core principles. So when we say it is decentralized, it is crypto native. And, that is usually considered the most important thing from a Web3 perspective. From a coding point of view, how things change depends on what you're trying to do. Usually in Web3, we are always going to try to use blockchain, smart contracts, and decentralized storage. Very rarely would we use cloud storage. We usually prefer to use decentralized storage and more of blockchain. Another question is about prerequisites of Web3. I did not understand the question. Could you repeat that question? Let me just quickly shut some of these windows down. And let me go back here. So here again, for this server side, what I have done is, firstly, we have created this basic code, okay, which is in the normal script. But in that, I am calling a PHP file, and that is why I put the code of the PHP file here. And the PHP file is simply generating a random number between 10 and 100. And it is then echoing that, the timestamp, along with a random number. But you can change this code to do whatever you want. All clear? What do we need to know to do this course? So Abhishek, that's a good point. So if you look at the topics, it starts from the absolute basics. So you really need not have any kind of background knowledge. So even if you're very new to developing, it doesn't make a difference. You can still use this. Yeah. Any other questions? Okay. I was from a commerce background. Can I start? Yeah, definitely you can. And if it's any consolation, I also happen to come from a commerce background. Honestly, at my time, there were no computer science degree programs in India. So don't worry about the fact that you come from a commerce background. I mean, as long as you're ready to work hard at it, you can easily become very good at programming. So the next thing that I want to teach you guys is how do we create hash functions or hash results of anything, right? So here, if you're not very comfortable with the concept of it, then I've also mentioned that in my Future Money playbook, just go and refer to chapter C9. There, technical crypto concepts like hash functions, digital signatures, RSA algorithm, all that is explained. So if you don't know anything about hash and crypto and all, you can go and have a look at it. And when I say crypto, I'm talking about cryptography, not cryptocurrency, right? So now what I'm going to show you is how do we generate hash results using PHP. Now specifically, I'm going to go into PHP because I'm a PHP developer, but it's very easy for you to find similar codes in whatever programming language you want to use. So let me show you how it would go. So here, if you can notice in the top, can you see in the browser something called plain text equal to Web3? Are you guys able to see that? Can you just give me a yes if it's visible? Awesome. So if the word that we have entered on top is Web3, what it is doing is it is showing us the hash results for the word Web3 in all the different hashes supported by PHP, starting all the way from MD2, MD4, MD5, going to all the versions of SHA, all the different hashes that are supported, it is going to show it to us. Now, usually we are not going to use MD2, MD5, those are all considered broken. Most of the time, we are going to end up using SHA3, which could be 512, 384. So different sizes of it we could use. I would say it's always better to use the most advanced hash which is available to us as of today. So as time passes, naturally, the more advanced hashes do come into the picture. The older ones get broken. So we need to stick with the best one. And if you change this input in any way, you just change it. I put my name instead. And I hit enter, immediately it is going to recalculate the hashes for that keyword. Of course, I want you to remember that, no, these are not sample hashes. So Yogananda, these are actually hashes for the word that we are entering. So what I'm doing, let me show you the code, is firstly, whatever we enter on top, we are getting that into our code through the get, and then we are calculating all the hashes for it. So as you change the word, the values are going to change. Now in reality, what is the hash of? So the hashes of the word. So for example, here, the word which we are using is ROHAS. So when the word ROHAS is hashed using MD2, this is going to be the hash result. When it is done using MD5, this is the hash. When it is done using, say, SHA512, this is the hash. So I'm showing it to you for all, but logically, when you're creating a program, you would pick and choose which hash you want to use. This one just shows you all the different hash functions supported by PHP. Okay. Shankar asked, what is the need for hash? Good question. So hash is used in many, many places. So firstly, if you're creating digital signatures, you can't do that without a hash. Secondly, if you're trying to verify that a particular file which has been downloaded by the user, is it authentic or not? Has it been tampered with? So that also we do by calculating the hash. Then I'm going to show you now in some time how we are going to, yes, Kavita is right, securing passwords. I'm going to go into depth in that how we are never supposed to maintain the user's passwords in plain text in our database. We hash them. And of course, I'm also going to teach you something called salt and pepper. Coming to that very soon. So even that's a place where hash is going to be used. Nitin's question is, the book that was mentioned, can we buy it? Or yeah, you can just download the PDF. I haven't really kept printed versions. You can just download the PDF version from my site. Now let's go to the next step. For a specific hash function, if we want to use, so now look at the code. It is going to show us the hash for SHA-512 for a given word. Let's see what it looks like. So now here you can see there is only one single hash generated. So here, whatever word we put in the top, so suppose I replace it with the word ROHAS. So here, now it's showing me the hash for that. So what this particular code does is, it will echo the hash only for a particular hash function which you have specified, and the keyword you can obviously keep changing. Later we are going to see how we are going to use this hashing within the code of the page and for a given password. I'm coming to that very soon. Now, if we want to see a list of all the hashing algorithms supported, let's have a look at that. So here it is showing us all the different hash functions that PHP supports. And then from that we can choose whatever we want. Now, if you want, you can also calculate the hash of a file. So you remember I told you that hashing is also used for file integrity checking, so that the user knows that the file he or she has downloaded has not been tampered. So we can hash an entire file. So in this example, I am going to hash a file called index.html located on example.com using SHA-512. So when I click on this, it gives me the result. And then naturally we can compare this result to know whether the file is genuine or not. So what you guys can do is you can just download this code, and here you can just keep changing the names of the file that you want to hash. Naturally, if it is on the same server as the code you're running, then you need not give the full path. You can just give the folder structure getting to the file name. But because this is external running on example.com, I have to give the entire URL. Is it clear? Any questions? Can you give me a quick yes if it's all clear? Awesome. Now let's get to something really interesting, which is called password, salt and pepper. So first of all, let's see how we can create complex passwords. Very simple to do in any language. I'm specifically talking about PHP. So here first I will show you the code for creating a 20-character password, and it contains alphabets, numbers and symbols. So for example, whenever I need to go to any website and enter a password, I just go to this calculator of my own and just copy paste a password. So every time it generates something new and complex. Now, first thing that we have to look here is a range has to be defined. Of course, you can call the variable whatever you want. What are the kinds of characters that it can use to create the password? So I have specified that it can use small alphabets, capitals and symbols and numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the complete set that we can use. So ideally we should have it in this way so that our password is more unpredictable and unlikely to be broken in a brute force attack. Then there's a bunch of code here which you can understand very simple. If you don't understand, doesn't matter, just copy paste and then start modifying. Like for example, instead of 20 characters, you could say 15, whatever. And then finally it is going to return the password to us and echo it. Let me show you what it looks like. So this is what the password looks like, and every time we refresh this page, the password is going to change. So it is changing constantly. Let me see some of your questions. Okay, I think you're having an issue with the streaming. Okay, so is this part clear? The basic password generation, is it clear to all of you? Give me a quick yes if it's clear. Awesome. Now let's go to the next step, and there is a concept called salt. I don't know if you guys have heard about it, but it's a very important concept. So when we talk about cryptography, salt is a secret. It's a number, phrase, I don't know, whatever you want to call it, is a string, which we are adding to a password before hashing it, right? So what happens is, one option is very simple, that whatever password the user enters, we hash it and store it in our database. But that is not considered secure enough. So what we do is we add a salt, and this salt is going to be different for every user. And then whatever the user has entered, we add the salt, we append it. So we are concatenating those two things, and this together is then hashed and put. So if someone gets hold of your database, or gets hold of all the stored hashes, and they try to use a rainbow table to brute force it, they will not be able to succeed, because in a rainbow table they will have all the common characters, words, and everything stored. But because we have added a salt, which could be it's an unpredictable kind of a string, when we concatenate and hash, it is next to impossible for someone to break that. Now, other than salt, there is also something called pepper. So this is another word, number, string, which is not stored in the database along with the password hash. And this can be the same for all the users, and we store it in a separate location. And finally, what we are going to do now is we take the password, append the salt, append the pepper, and that entire string we hash and store it into our database. So as of today, that is considered probably the most secure way of doing it. Nathan's question is rainbow tables. So rainbow tables is where we can maintain. Okay, I'll give you an example. So we know that, let's say in the past MD5 was used. So we know that sites are going to store the MD5 hash versions of passwords. So what we could do is we could create this table which has billions of possible passwords and the hashes of each of them. So it would say A, this is the hash, B, this is the hash, C. Then it would take all single character, double character, 3 characters, 4 characters, 5 characters, and we start to build a rainbow table. Once we have that with us, whenever we get any hash, we can run it against the rainbow table and immediately come to know what was the original password. Hope that's clear to you, Nitin. Yeah. So Gagan's question is about pepper. So salt and pepper are basically the same thing, that they are random strings that we are generating. The only difference is the salt changes for each user, and it is stored in the database along with the password hash. Pepper is a standard thing which we will use for all our users. Let me show it to you in a code so it will become clearer for you. So here what I am doing is that let's presume that my user has submitted this password, Amsterdam-44. So this has come from our user. Now we call this variable as password underscore plain text, that this is what the user sent us and we are never going to store it. Next step is we are going to generate a salt, and I'm going to do a 16-character salt, which could be small alphabets, capitals, numbers, and symbols. Okay, that 16-character code, when we create it, we will put it as a variable called $salt. Then I'm going to use something called $pepper, which is a fixed string. All the users of my site, I'm going to use the same pepper for all of them, but for each of them the salt is different. Then I am going to generate, or rather I am going to create this new variable which is password salt pepper, which is the password plain text sent by the user. I'm appending the salt to it, I'm appending the pepper to it, and that entire long thing I am then going to hash. And I can use 2 different hashing functions. So one is a default in PHP called bcrypt, and the other one is SHA-512. So let me show you what this would look like. So here we can see that the user entered Amsterdam-44. We generated this salt. This was the standard pepper. This is the bcrypt hashed password, and this is the SHA hashed password. So in the database, we are not going to store this. We are going to store the salt, and we are going to store either this or this. Is it clear to you? Any complications, questions? And every time that we refresh, so we can see that obviously this is the user's passwords, we are not changing, but the salt can keep changing every time if you want. Pepper doesn't change and the hash changes every single time. So this kind of makes it next to impossible for someone to run a brute force attack or a rainbow table led attack on our systems. All clear? Awesome. So again, here the codes are all available to you. The best way to understand it is download the code, read it line by line, and start making small tweaks, and you will be able to do it. Now, the next thing that I want to talk to you about is how to generate cryptographically strong pseudo-random numbers. So in the world of cryptography, you will keep hearing about this concept of pseudo-random numbers or random numbers, right? Now, one thing we've got to remember is we cannot generate random numbers, true random numbers using software. They are always called pseudo-random, but they are pretty difficult to predict. So this is not ideal. Ideal would be some kind of a specialized hardware that we would use. But this is what we are going to do for cryptographically strong pseudo-random numbers. I'll give you a couple of use cases also. Basic question, hash is a one-way function. So when we need to verify the user's password, how do we do that? So Keshav, what we do in that case is the user enters the password, we do the salt pepper, then we generate the hash and we compare the hashes. That the hash which we have stored from before and the hash which is being generated now, is it the same or not? In PHP now with things like bcrypt, even though the hash will look different, it will be able to verify and tell us whether it is authentic or not. So we are not brute forcing the hash, we are simply comparing the two hashes. I hope that's clear to you guys. Now I'll give you a use case of this. Have you guys heard about blockchain based gambling and lottery systems? Have you guys ever heard about it? So I've written about a few of the projects. Offhand I cannot remember, but the concept is also called as the prediction markets. So prediction market is where it's kind of like gambling, where you're predicting stuff, and depending upon your predictions you could make money. So for example, do any of you believe that Donald Trump could become the US president in 2024? Anyone? Give me a yes or a no. So Keshav says yes in pancake swap. Yeah, Keshav, you're right. It was pancake swap. Okay, so now many of you are saying no. Now, if you go to, I'm not sure if it's pancake swap, but if you go to a prediction market, you can actually place a bet. And if Donald Trump does become the president in 2024, you get a lot of money. If it doesn't, you lose your money. So now in these kind of lottery systems, some could be based on a real life event like Donald Trump winning or losing an election, or second could be random numbers. So like a raffle where we say, okay, the answer could be between 1 and 1000. You put a bet like a lottery ticket on which number will come. And if your number comes, then you get a prize. If it doesn't, you lose your money. So now in this situation, how are we going to generate those numbers? So if we use a predictable method, then some clever guy can predict what the number is going to be. That is when things like random number generators come in. So when we do it in softwares, we call it pseudo random number generators, but they're pretty strong. I'm not saying they're not so strong. Is that clear? So here I've shown you two methods in which you can do it. And you can use it for generating salts, keys, initialization vector, which is something I'm going to teach you in a few minutes from now. So when we run this, the result could be something like a 10-character string like this. And this string is considered cryptographically secure pseudo-random number. So we can kind of run our lottery or whatever other thing that we wanted based on that. And then there's another one if you want to generate, say, integers. So we are generating integers here, or numbers, integers which are from -100 to +100. So between that, every time we refresh, something new is going to be generated. You could also, there are certain such kind of prediction sites where you can bet on heads or tails. Okay, but nobody's going to physically sit and do head or tail. So again, you could run a pseudo random number generator and it would keep generating H or T, head or tail. And you could run your betting system on that. Is it clear? Any questions? Give me a yes if it's all clear. Awesome. Now, the last thing that I want to talk about is encryption and decryption. Now here again, if you are not familiar with the concepts, You can read the chapter in the book. First step, we are going to see what are the different algorithms supported by PHP. So let's just click on this. So PHP gives me a whole bunch of algorithms which I can use. All of these are supported, but by and large, we would only use something called AES, and I'll explain to you why. So AES, which is the Advanced Encryption Standard. So this globally, we always look up to something called the NIST. You must have heard about NIST, right? So this is the National Institute of Standards and Technology of the US. We always look to them about which algorithm to use. So they chose AES. Before that, they used to use something called DES, which started all the way in 1997. Then it was replaced by AES many years ago. As of right now, it is considered the strongest. Right. Now, this is a symmetric key algorithm, which means the same password or key is used to encrypt as well as decrypt, or lock and unlock. Now, one thing that I want you to understand here, so let me first show it to you and then I'll explain it to you. Whenever we take any plain text, so suppose I've just taken my name. In AES, what it does is it generates something called an initialization vector and something called an encryption key. Usually when we look at symmetric passwords, we just use one key, right? So we just put a password, but no, that's not how it works. Here, we need two things, IV and an encryption key. So if we want to decrypt this data, we need to provide the IV and we need to provide this encryption key along with this encrypted data that we have, and then it can decrypt and show us the original. Now I will show you another interesting thing. Suppose I refresh. IV has changed and the encryption key has changed. But do you realize nothing else really changes, right? This encrypted data keeps changing, but it doesn't matter to you. So what happens is, it is now next to impossible for anyone to predict this. The same plain text, when used with different IVs and keys, is very easy to encrypt and decrypt. So we can change this regularly also. And unless both are available, no one will be able to decrypt this. So what we can do is, one of this we can provide the user and this we can keep with us. So it becomes next to impossible now for a hacker, because let's say the hacker has managed to steal this. So are you guys familiar with the concept of password sniffing? You know, when you enter anything on your computer and it goes through the internet, maybe through Wi-Fi, it can be stolen on the way using password sniffing or data sniffing. Awesome. So many of you do know that. So now suppose you were sitting at your house and you are entering in the encryption key. Now, if it's going to go through the internet, even if you are using SSL, it can be very easily sniffed. So that is why I always say don't use public Wi-Fi, right? If you're using a public Wi-Fi, like say at a coffee shop, at a cyber cafe, if they still exist, airport, it is very easy to get that, sniff it out. But here we are not so worried about it, because also the initialization vector needs to be provided, which could come from a different source. So that is how AES is really a much better thing of use. Shankar's question is Web3 all about security? No, it's not all about security, but security is a very important part, because in Web3 we are talking about not maintaining user credentials at the centralized level. Like today, when you guys log into a site, you use simple username password, or let's say, or you use a Google login or something like that. What does that mean? It means that Google keeps your password data. But suppose we use something like MetaMask. In that case, we don't know who the user is. MetaMask simply authenticates by sending a digitally signed message. So when we use such kind of things, we need to be very careful how we are storing all the user passwords and all. And that is the reason in Web3 there is a lot of emphasis on security, because everything is decentralized. And when you decentralize things, the chances of hacking is much more actually, not less, it is more. So that's the reason a lot of emphasis is given on security. Avinash's question is, how will this be shared with the recipient? So Avinash, one way of sharing it, in fact, I want you guys to give me an answer. Tell me where we should be stored, where we could store this. Jatin says Diffie-Hellman. Well, that's an algorithm only. I'm saying, where should this be stored? say the initialization vector or the encryption key. And we've covered it today only. We could do it in the local storage. So you get it, that's where local storage can be used. So the user also doesn't need to bother too much. So some part of this could be where the user enters, another thing could be on the local storage, and then we could create, decrypt, encrypt, and then pass the final result. So it's up to you what kind of application you want to make from this. So as you guys start to learn more and more, so I want you guys to do this entire course, and then we can actually pick up some simple applications that we can build. And we can do that as a practical application. Hope that's clear to what I'm saying. Is it all clear? Give me a quick yes if everything is clear so far. Awesome. Now what I've also done is here I've given you two things to try out. So suppose we want to use public key encryption. Again, read it up on my book if you don't know what it means. It's where we use a different key to encrypt and different to decrypt. So here you can just try them out. So, once you've read the basics of it, you could just click and use these. So, you'll understand what is a private key, what is a public key, and how exactly RSA algorithm works. So I've even explained the mathematics of the RSA algorithm. And then I want you to just experiment with these two files. So this one is called the Stanford JavaScript Crypto Library, very useful. And it's a very good way of experimenting. So, you can enter some password here, and then you can put a message. And then it starts to generate all sorts of data. And this is a very useful thing, but I don't want to get into it right now because it may seem very complex. Once you have tried out all the things that we've discussed today, and after that, you do all the practicals, then you can try out these last two things. Let me know if you have any questions. Is it all clear? Any questions? Shankar's question is, so is Web3 improving from normal Web2 with some basics? Okay, so let's do one thing. Let me tell you something simple. So when you go to this, let's go to this, what is Web3, right? So when we talk about Web1, that was the earlier internet where I don't think most of you were using it. Any of you here, you used to use this older one about till the year 2001, 2002. Okay. So at that time, what used to happen is most websites are very static. So Gagan, okay, you used to use it. So it was very static and boring, and you just had a place where companies would put information, we would read it. Then came Web 2.0, where we have things like Facebook and Google coming in, and everything started to get more interactive. And Web 3 is the next generation where everything is trying to become these four things: trustless, crypto native, decentralized, and permissionless. So what does that mean? Trustless means we don't trust people anymore, we trust code. So if MetaMask says something, gives a digitally signed thing, we trust it. Crypto native means wherever possible for payments, we use cryptocurrencies. Decentralized means instead of companies like Google and Facebook owning all the data of the world, this can be kept decentralized across different platforms. So in this course, I've spoken a lot about decentralized storage, things like CR network, Filecoin, those come into the picture. And finally, permissionless. So have you guys ever tried to place an ad on Instagram? Any of you? I mean, maybe as part of your business, you place ads, right? So have you realized that you need to take permission from Instagram to put an ad? Have you noticed that? And that's ridiculous. I mean, sometimes I get angry because they would reject an ad for no rhyme or reason, right? Just because their artificial intelligence system doesn't understand what you're trying to advertise. But Vivan says they don't allow Web3 ads. Yeah, crypto ads. So that's unfair, right? Crypto is not illegal. If it's illegal, I can understand. But these platforms decide what you can and cannot do. Like, can you imagine when Donald Trump was the president of the US, Twitter banned his Twitter account? I mean, just look at how ridiculous it sounds. He is the president of the country where Twitter is incorporated, and they banned his Twitter account. Do you get how ridiculous that sounds? Okay, so in Web3, everything would become permissionless, where none of these centralized parties would be able to stop you from doing something. So if you want to post some content, you want to do stuff, there's no one you need to take permission from. So that is these are the 4 core principles of Web3. Deserved it. See, while I do agree that a lot of what he said was objectionable to a lot of people, but who gives Twitter the authority to censor? See, tomorrow Twitter could then censor anybody they feel like, right? And people have a right to speak. And if you don't like what Trump says, why don't you unfollow him? Why don't you block him? But why give this power to a third-party platform to control what people can and cannot do? So that's the concept. Someone's question is it open source? So almost everything that we see in Web3 is open source. So almost everything, all the software that you're going to use, all the platforms are open source. Vivan says, but companies can have their own policies, right? Even a Web3 can have some governance guidelines. Vivan, definitely it can. Although ideally in a totally Web3 world, there should be no concept of permissions. But you're right. I mean, companies can do it. There's no rule. See, Web3 is not a legal term. It's a tech concept. So you can obviously play around. Like, after all, nothing in the world is purely decentralized, right? Even Bitcoin is not purely decentralized. So I get that. Is this Carter Web3? I don't know what that means. Shankar, could you re-explain what your question is? Any other questions you guys have? So later when you guys go through this course, so as you can see, it starts with the syllabus and everything. There's a mind map, tech careers, then it goes into blockchain 101. So all the major things that you need to understand about blockchain are here. Creator, okay, is Creator Web3? No, I don't think it is yet, but it has one feature which is Web3, we could say, which is the Learn token, which is integrated. So Learn is a crypto asset that all of you earn every time you attend these sessions. So Creator is getting there. Soon it will be Web3, I'm hoping. So here, the second one is this. Then the third one is build your own blockchain with all the code examples here. Then the coding basics, what we have done today, we will add, I'll keep adding more to it. Then there is blockchain APIs, crypto APIs, and the Web3 tech stack for developers. And then you can test your knowledge. And optionally, you can always get certified, but there's a fee for that. Okay, so Bhavin says, I think the level of decentralization depends upon the number of nodes for a particular blockchain. Yes, Bhavin, you're quite right. So one is the number of nodes, but then also consider it's not just nodes. What about the Bitcoin core software which runs Bitcoin? So while there may be many people running the nodes in a decentralized fashion, the software of Bitcoin, the core, is only run by 6 or 7 people. Obviously, thousands of people cannot do that. So in that way, Bitcoin does become quite centralized. Karan says, please add the website URL in the WhatsApp group. Yeah, Karan, I have added it today. I can put it again, but it's already there. Yeah. Questions? Anything else you guys would like to know about? So I'm hoping you guys go through all these coding examples and then let's build some, interactively. Do you guys want to build a project live? Okay, actually that's going to happen in Encrypt 2022. Sorry, that's starting off tomorrow. And you guys can, here Vivan has put the URL. So a lot of teams are there who are going to be collaboratively building blockchain and Web3 based solutions. So have a look at them. And then later, maybe we can do a session where we all can get together and build something from the ground up. Some simple kind of project. So why don't you guys come out with some ideas for a simple project that we can build? You can type it in right now if you have some ideas. Yuganka asks, how is a governance token different from a normal token? So Yuganka, I think I would recommend that today at 5 o'clock, I'm doing a session on token economics. And actually the question that you've asked is part of it. So if you attend that at 5, I'll be able to go into this in a lot more detail. Another question is, Bitcoin is not an open source like Ethereum. No, I disagree. Both are the same. Their codes are controlled by a bunch of programmers. But in terms of being open source, I would say they are identical. I mean, they're all open source, right? What is the criteria for picking up a set of transactions for a block? Is it only gas fee? So Gagan, that's a good question, and it depends from blockchain to blockchain. In a pure proof of work, yes, the gas fee would be the most important factor. But ideally speaking, blockchains are not supposed to allow you to pick and choose, and ideally they should take all in the order in which they were collected. But it's a very tough question to answer because in different very differently. If it is not, out of the, can you give a glimpse of the legal compliance? So again, legal compliance, totally different topic. I teach a course called blockchain law where we go into that. So this may not be the right one. This session is more tech in nature. Another question is the Flux network good for dApps? That's a good one, Flux. So, but actually in this course, this Web3 developer course, I mentioned about 35 different tools and platforms. I don't think I've added Flux to it. I think there are a lot of better versions, better software than Flux. So I've added those. Gagan says, as a miner, should I not pick up just one transaction, create the nonce, get the block added on the network quickly? Yeah, so Gagan, definitely you could do that, but you got to remember one thing. Your ability to mine a block doesn't depend upon the number of transactions in it. It is not like if there is one transaction, the nonce can be calculated faster. No. If you haven't attended that, I've done 2 sessions on Creator itself for understanding the Bitcoin white paper. We went into it in detail. Have a look at those videos. It does not matter how many transactions there are because you are ultimately only going to take the hash, the Merkle root. The Merkle root, whether it is of one transaction or 1,000 transactions, makes no difference. So your speed doesn't change. Vivan has also put some a link to some of the legal sessions that I've done. So please feel free to go back and have a look at them. There are any solutions for infinite loops? One thing I know. That's a good point. So when gas fee comes in, if you're running a smart contract which is creating far too many transactions, when the amount of gas you're ready to pay runs out, the transaction stops. So that is one of the reasons that you actually have this concept of gas fees. But obviously that would work only on certain kinds of blockchains, not everywhere. But that's a good question. That's a good point. Any other questions you guys have? So think about it, come out with some ideas, and maybe we'll do a live session after Encrypt 2022 is over, where we could build something from the ground up, some kind of a simple application. And the WhatsApp group that we were talking about, so I've created a couple of WhatsApp. So if you want to do the Web3 developer course, you can join the LinkedIn group also. Let me just try to share the URL. Give me a second. I'll just one sec. Okay, I don't know, I can't seem to find the URL here, but I'll share it with you guys. Does anyone have the URL of the group? Could you just, yeah, okay, I found it. So if you are interested in being part of the group, I've sent you the WhatsApp thing, sorry, the LinkedIn one, and I will also send you the WhatsApp. Give me a second. Okay. So there are 2 WhatsApp groups. So because WhatsApp has a limit on, I think, 512 members. So I think one group is full, but the other is not full yet. So I've put both the links. So just see, you can join whichever one has space in it. I think the second one would, but you could just try whichever one it is. Group 2 has space. Yeah, okay. So you could just try. I think 512 is the maximum, 513 is the maximum limit. Creator plus 512. So you could just try that out. And oh, Gagan has the formula for that. Any other questions? Anything else? So I'll do another session with you guys soon on crypto APIs. I'll do another one on blockchain APIs. And in the meanwhile, you could go through this Web3 developer program and let me know if you have any issues. Yuganka's question, how is the final block miner chosen when multiple miners find different nonces? So Yuganka, good question. Again, you could go through the Bitcoin white paper, but to briefly answer your question. So what happens is, whenever you successfully mine, which means you've calculated a nonce, you broadcast it to the network, and then different nodes pick up at different, there's no way to predict who's picking up what. So if I pick up a particular person's nonce, I will start following that person and go to the next one. Somebody else may have picked up from another successful miner, and suddenly we see multiple chains running. And then something called a reorg happens, which happens, I think, every 6 blocks, if I'm not mistaken, in Bitcoin, if I remember correctly. At that time, the blockchain will delete all the shorter chains and only the longest remains. So that concept is called a reorg. So you could go through that video, it'll explain it more in detail. Keeping your teaching interface clean by removing unwanted tabs. Yeah, Gagan, that's what even I thought. You know, when I'm learning something, I don't want too much mess around. I need it to be as clean. So I'm glad you liked it. I've kept a very simple interface. Yes, the blockchain developer course has been renamed to Web3 Developer. So I'll be doing multiple sessions. So for example, I'm doing the session on Fridays and Shinam will be doing some sessions for you on Monday. So the best thing is just follow us on Creator, because that's where all the sessions are happening. So every time we have the session, you can get notified. And I've also shared the LinkedIn group and the WhatsApp group. So I always post it there. Another question is, we can consider it valid once it has 6 confirmations. Yes, so you're right on that. That's the reason we wait for 1 hour for a Bitcoin transaction to go through, because on an average, each block or each confirmation takes 10 minutes and 6 takes 60 minutes. But again, this is average. It's not always every block is 10. It could be less, it could be more, but on an average it is 10. And that's why we wait for 6 confirmations. So you remember that story I always say about this coffee shop in Bangalore? If you're paying in Paytm, he gives you the coffee first and you can pay later. But if you're paying in crypto or Bitcoin, they will say, pay first, then we'll give you coffee, because it's going to take 1 hour for your transaction to be confirmed. However, if we use things like Lightning Network, then it happens instantly. So if you're in El Salvador having a burger, it happens instantly because of Lightning Network. You're not using core Bitcoin for that, you're using an L2. And in fact, are you guys aware that a new country now has accepted Tron as its official blockchain and crypto? So Tron, that's TRX, has now become legal tender in this country called, I've forgotten the name, I just saw it this morning. It's a small country called Guyana or something like that. Just give me a second. Dominica, sorry. It's in Dominica. Yeah. By the way, by any chance, is anybody from Dominica on this session here? No, okay. So I'll try to find out from someone there what it actually means for them. But it's a pretty interesting development. Someone's asked about layer 1 and layer 2. So that is explained in detail in this Web3 course. You can just go through that. In the video, I've explained in detail, but to very briefly put it, what we mean, so there is L0, L1, L2. L1 is a blockchain which settles transactions on its own without needing another network. So example would be BTC, Bitcoin. L2 connects to an L1 for finality. So example could be Polygon. They have a chain. Another example could be things like Lightning Network. That's an L2. And L0 is a framework which you can use to create L1s. So usually we say Polkadot, Cosmos, Horizon, they come under L0. So there are usually 3 types, L0, L1 and L2. Yeah, thank you, Bhavin. I'm glad you liked the session. The recorded version will also be available across YouTube, LinkedIn, Twitter. So feel free to look at that also. And Vivan has posted the link for the 5 o'clock session. So I'll see you guys there. That is going to be on token economics, which is the finance part or the economics part of the field. For speeding up transactions, we use layer 2. Yes, you're right. Layer 2 is used for scalability. So it speeds up things, makes things much faster. Okay, bye-bye. It was nice speaking to all of you. See you guys.